We're talking about polar coordinates, and then we'll get into polar curves. I don't know what you remember from pre-calculus, but in pre-calculus you probably remember there's a bunch of circles. And when you're trying to figure out what the polar coordinate is of something, or if you're trying to graph a polar coordinate, you're trying to find a point that's on one of these circles. And so what you do with polar coordinates is you have an R value and an angle. The R represents the radius, so that tells you which circle you're on. For example, if I was talking about this point right here, the R would represent 3 because I'm on the radius of 3. I'm on the circle, like the third circle. If I was on this point right here, then that would be a radius of 2. If I was on this point, again a radius of 2. If I was over here, that would be a radius of 1. Now the location of that point, besides the fact of what circle you're on, represents the angle, and the angle is the distance from either the right or the left. It just depends on where you're talking about, and I'll show you that. So if I have a coordinate 5 pi over 3, first I want to graph it, and then next I want to write it in rectangular coordinates. Rectangular coordinates are your normal coordinates that you're used to. So the 5 means that I'm on the circle where the radius is 5. So it's almost like I have this circle that's out here, and I know that my point is somewhere along that circle. The pi over 3 means that I start over here on the right. If it's positive, you start on the right. And then it's pi over 3, so I'm going to come up. So that means my point is right here. Now I'm going to draw this little triangle here, just so that you can see it. That's the 5. Pi over 3 is 60, so that's the 60. So to write it in rectangular coordinates, I need to know this value and this value. Now, if you know what you remember about trig, you might can figure it out. The x is across from 30. 30 would be half of what the hypotenuse is. 60 is across from the y, which is 30 times the square root of 3. If you would rather do sine of 60 equals y over 5 and then solve for y and get a decimal, that's okay too. Same thing for x. So there's the graph, and there's the rectangular coordinates. Alright, let's say we have this rectangular coordinate. Remember that 7 is the radius, 0 is the angle. So that means that I'm on this circle out here where the radius is 7. And it means my angle went 0, so I'm right there. Well, that coordinate is the same in rectangular coordinates. It's still 7, 0. Okay. This one means that I'm on this circle of a radius of 2. Doesn't matter that it's negative when I'm thinking about just the circle. So my point is somewhere along that circle. The fact that it's negative means I start here. Normally you start over on the right, but since it's negative, it starts on the left. And then normally when you start on the right, when I start over here, my angle goes up that way. So I continue that same direction, which means pi over 2 from that angle is going to end up being right there, because I have to go that direction. If it would have said negative pi over 2, then I would have started over here, and then I would have went up to there. So the negatives tell you direction, and it tells you where to start. So we're talking about the point that's on the 2, and it's on the axis. So you can look at that and tell that that point is 0, negative 2. Alright, and then we've got 1/2 7 pi over 6. 1/2 is the radius of the circle. 7 pi over 6 is the angle. This is 7 times 30, so we're talking about 210, which means we're in this third quadrant here. The 1/2 is the hypotenuse. Okay, if that's 7 times 30, which is 210, then this angle's got to be the 30 degrees. And then we could use our rules about that special triangle to find all the other sides. I know that across from the 30 is the y, and it's half of the hypotenuse. I know that across from the 60 is the x, and it's a fourth times square root of 3. Again, if you wanted to do sine of 30 equals y over half, and then cosine of 30 equals x over half, you could figure that out as well, or you could use the decimals. So that's polar to rectangular. Well, now we're going to look at rectangular to polar. So if I have -1, -1, graph that like normal, down 1, over 1. So there's where that point is located. So what I need to figure out in order to write it in polar form is I need to figure out what circle that radius is. And the way to do it is to draw that little triangle, and I know that the hypotenuse is the r, and then I can find that angle from there. So I can do the square root of 1 squared plus 1 squared to get the square root of 2. So the r in the polar coordinate is square root of 2. It comes first. And then I need to figure out that angle. Well, since these two sides are both 1, I know the angle is going to be pi over 4. But you could use tangent of the angle or sine or cosine or something to try to figure that out if you wanted to. Now, that's not exactly correct, because square root of 2 means that I start over on the right. Pi over 4 means I go up pi over 4. Well, if I'm starting over here and then going pi over 4, that means I have to have a negative on the square root. So when you're writing your answer, you have to write it and think about the location. Now, there's other ways to write it, and sometimes you're just going to have to write it 2 or 3 ways. Like it might say change it and then write it several ways. So I want you to know you could write it as square root of 2, and then you could start here and go around to it, and I could find out that there's 1, 2, 3, 4, 5. It's 5 pi over 4. You could do negative square root of 2 again, and instead of going like down, you could go all the way around. I think it comes out to be negative 7 pi over 4. You could also do square root of 2 and then go backwards with the angle. Instead of positive 5 pi over 4, you could do, I think it would be negative 3 pi over 4. So in these answers, you're going to have to change it to one of them, but then you're going to have to probably write it 2 or 3 other ways. Okay, so this one is negative 5, 0. This is the r and the theta. Negative 5, 0 means that I'm starting at negative 5 and I'm going 0. That's pretty much the only way that you could write that one. And you know what? This was not r and theta because I'm trying to go the other way. I'm sorry. This represents the x and the y. Now, to write it in polar, I was right that the polar, you could write it as negative 5, 0 because we're trying to change these to polar. Another thing you could do is you could start over here and say positive 5 and then go that much, which is pi. You could say positive 5 and go backwards. Or you could say negative 5 and go backwards. Okay. Negative 4, 3. We're trying to go to polar again. So there's our point. First thing I need to know is what's that radius. So I could do the Pythagorean theorem, get 5. So I'm going to have 5 comma something. Then I need to know that angle. This isn't a special angle, so I could do tangent of the angle equals 4/3, and then do the inverse. And whenever we do this, if you want to leave it in radians so you're not trying to find the degrees and having to change the mode, that would be okay. I got 0.927 when I do tangent inverse of 4/3. So that's not our full point though, because we're starting here and going that way. Well, since we're starting over on the left, that makes it negative, and since we're going backwards with the angle, that makes that negative. Now, if I wanted to start over here, then to get the angle that I need, I'm going to go from here to there, which would be pi minus that, which is 2.214. I could also start at 5 and I could go this way, which would be pi plus that 0.927. And you get 4.068. And then lastly, I could start at -5, which is where I was starting originally with the purple, but I'd have to go backwards, which would be 2 pi minus that 0.927. And I would get 5.355. And it's negative because, or it's positive, I'm sorry, because that's the correct direction. Now, there's lots of things that you can do with polar graphs. That's the coordinates. We also want to talk about polar graphs. There's two really important ones I want you to know. One of them is r equals 5, and the other is the angle equals pi over 3. Now, it would be r equals something else, or angle equals something else, but that's the forms that I really want you to know. The r means the radius is 5. Well, that means you're talking about a circle. And the formula for a circle is x squared plus y squared equals r squared. So that particular graph is x squared plus y squared equals 25. Angle equals pi over 3. That means that we want to figure out what the equation is of any point whose angle is pi over 3. So graphically, that's saying that I go to pi over 3, I draw a line, and I want to know the equation of that line, because if this is pi over 3, this would be pi over 3 as well, and any point along that line would be on the line angle equals pi over 3. So I'm just needing to figure out what that angle is. What you can do is you could say that tangent of the angle equals y over x, because that's the formula. Opposite over adjacent, y is opposite, x is adjacent. We could take tangent of pi over 3, and that equals y over x. And tangent of pi over 3, and that's tangent of 60, so it would be opposite over adjacent. That would be square root of 3 equals y over x. If you solve for y, then you would get y equals square root of 3 times x, and this would be the equation. So there's two really important ones here, and I want you to know. The one where that equals a circle, and it's just the circle equation, and the one where that is a line, and you end up with an equation y equals mx, and it goes through 0, 0, so there's no y-intercept. Now for the calculus for polar coordinates and polar curves. There's several things we're going to do with calculus, but the one that I want to practice on today is finding the slope, so I'm going to give you a formula. Normally, you're going to start with r equals f of theta, meaning that you have some kind of equation for what f of x is. You need to know that x is always, you're using the cosine part of the coordinate, and so x is always whatever the radius is times the cosine of the angle. And r represents a function, so it's normally f of theta cosine of theta. If x is the cosine coordinate, that means that y is the sine coordinate, which would be f of theta sine of theta. And your derivative formula, it's kind of like using parametric equations. You find the derivative of y over the derivative of x. And so if I do the product rule for y, I get that. If I do the product rule for x, I get that. You could memorize it, or when you rewrite it, then you could find the derivative that way. So let me show you an example of that. I want to find the derivative of this one at 3 pi over 2. So first thing I'm going to have to do is I've got to rewrite what x is and what y is. X represents r times cosine of the angle. So here's r, and I'm going to multiply by cosine. Y represents r times sine of the angle. Now, you're going to have to find the derivative here. You could multiply that out first and then find the derivative, or you could just go ahead and do the product rule, whatever's easier for you. I'm just going to call it x prime, and I'm just going to do the product rule. First times the derivative of the second plus the second, we'll come back to y, I'm going to do it underneath it, plus the second times the derivative of the first. Simplify it a little bit because it'll make it easier, and I'm going to distribute that right there. Negative 2 sine theta plus, actually be a negative, 3 sine squared of theta, and then multiply the next one, 3 cosine squared theta. Go ahead and plug in your pi over 2, or your 3 pi over 2. Sine of 3 pi over 2, well, that's 0, negative 1, so that's negative 1. So we'd have negative 2 times negative 1. And then it's going to be negative 1 squared, and then the cosine is 0. So you get negative 1 for the x coordinate of the derivative. Alright, let's do the y coordinate of the derivative. We already figured out that y was 2 plus 3 sine of theta times sine of theta. So the derivative, I'm going to do the first times the derivative of the second plus the second times the derivative of the first. So at 3 pi over 2 again, well, it'll be easier to simplify. Sometimes it needs to be and sometimes it doesn't, but I'm going to go ahead and simplify. 2 cosine theta plus 3 sine theta cosine theta plus 3 sine theta cosine theta. You could combine that if it just asked what the derivative was and it was looking at multiple choice. That's how you would do that. But then I want to plug in the 3 pi over 2. Cosine of 3 pi over 2 is 0. Sine is negative 1. Cosine is 0. So we get 0 for the y coordinate. So if I want to figure out dy dx, or the slope of that polar curve at 3 pi over 2, then I take the x one and put it on the bottom, the y one on top. So in this case, the slope would be 0 of this polar curve. Okay, we'll stop there. You do have some try problems that I want you to do. First of all, we've got 2, 3 pi over 2, and I want you to change that to rectangular coordinates. Then we have 1 square root of 3. I want you to change that to polar. And I want you to write 2 other ways to write it. And then I want you to find dy dx for the polar curve r equals 3 plus cosine theta at the angle of pi.